working with Substance Painter, you have to be mindful of the texturing science, if you will, that goes into the creation of all these two-dimensional texture maps. Substance Painter is working within what's called the PBR Workflow, which defines how a number of different input textures determines how the surface is going to be represented by the light going across the scene itself, across the model. Now, if I zoom out here real fast, I want you to look real carefully. I've just applied a simple substance. I think it's called glossy terracotta to the body of my turtle here, and I want you to look real carefully at the specular highlight that's showing up here on the turtle and how it compares to the specular highlight that shows up here on the body. So the shell looks kind of plasticky, if you will, and this doesn't. If I hold down the shift key and do the right mouse button, I can move my light source around in the scene. And this is a great method for us to understand how the light is slowly moving across the surface and how that change determines our understanding of what type of surface this is. The PBR workflow takes a number of different inputs and uses that information almost as an aggregate to define the surface characteristics. It's not just one channel, it's 5 different channels. And if you look carefully, we can start to see it. So I've selected the glossy terracotta fill layer inside of my layers palette. And down here, I'm in the material selection now. Down here, we can see all the different channels that are being used to describe this texture. Of course, color, as one might imagine, is just the surface color. This is a two-dimensional image of some terracotta that's been overlaid using my UVs, and this is the result we get. Whatever's in the color channel is just basically going to serve as the color of our object. Think of this kind of like the body paint, if you will, of a car. But it's not the only channel that determines how the light is going to interact with the surface. If we start to incorporate height, well, now check it out. You can see very directly here that we're getting the smallest illusion of surface relief. This is kind of like a bump map, if you will, if you're coming from the Arnold or other rendering engine. The height map starts to determine and create these micro moments across the surface that's going to break up the specular highlight and give us the illusion of pits and valleys. In addition, we also have what's called the roughness. And the roughness channel determines how big or small the specular highlight is across the surface of our object. Now, if I was to deactivate the roughness here, you can see that the highlights are beginning to change. Now, down in this particular substance, we have a slider here called terracotta roughness. Now, I want you to watch very carefully at the specular highlight here. As I change the value, you can see that specular highlight kind of goes away, and now it becomes a little bit more matte. It's not very shiny. If I lower that roughness, now it's getting more shiny and it's starting to look wet. The fall off of our specular highlight it determines our understanding of what surface this is. With a low roughness value, we're now like in metals, right? We have the illusion that it's super shiny. With high roughness values, we're now starting to make it look more matte, less shiny. So the roughness determines the shininess, if you will, of our object. And as I orbit around the scene here, I'm looking at the specular highlight run across the surface and enjoying how it's reproducing the illusion of terracotta for this little turtle. Now, the metal channel here is going to determine the metallic factors that go into the creation of this material itself. Well, this particular object doesn't have any metallic nature to it, so we're not really seeing much of an impact. And then finally, we have the normal map. And this object begins to come to life once we add in this other layer of surface relief. You can see what it looks like there. As I turn it on and off, we're getting a very different illusion of surface relief, which is pretty cool. Now, all 5 of these channels are working together as a combined aggregate to serve the overall material itself. And we're going to have a lot of these different layers inside of our texture set that's going to serve and funnel the material. Here's kind of a cool thing to help illustrate this idea. Right now, the viewport, we're looking at the material. So we're looking at the combined results of all of our input channels. However, we can also look at the individual channels. This is what the base color looks like. If we go into this pull-down menu, hey, look, this is what the roughness value is doing. The roughness channel is basically nothing more than a black and white image that's determining the specularity of our object, which is pretty cool. Here's a great keyboard shortcut. If you hit the C key on your keyboard, it's going to cycle through all the channels. This isn't a metallic object, so we're not seeing any information preserved in the metallic channel. Here's the normal channel. This is the surface relief, one of the things that creates all the bumps and grooves. And this is the normal plus the height map, all combined together. Hitting the M key, M is in material, will bring us back to that aggregate view. You can also get the exact same thing by going into the pull-down menu as well. So this PBR workflow really takes in all of these individual inputs and combines them to create our understanding of how the light is interacting with the surface. We're going to be using all of these channels at every single stage in the construction of our textures for our little turtle character.